So now that we have the fundamental matrix, well, so what? Well, as we said, it relates between the pixel coordinates in the two views. And it's much more general than the essential matrix because we've removed the need to know the intrinsic parameters. If you told me the intrinsics, okay, then I could figure out the rays that correspond. And if I know the rays that correspond in the 3D camera coordinates, I could compute the essential matrix. I could figure out the real rotation or translation. But if I have two arbitrary cameras that aren't even necessarily the same, the fundamental matrix allows me to relate them without worrying about the intrinsics or the extrinsics. So the bottom line is, if we estimate the fundamental matrix from the correspondences, then we can reconstruct our epipolar geometry without having to worry at all about the intrinsics or extrinsics of the camera. And that's what's done here. Here you see two pictures. I think this is also courtesy of stealing from Andrew Zisserman. And you have some pixels on the left and some pixels on the right, and then they were put into correspondence. The idea is I gave you corresponding points, and now the lines that are drawn on here, those are the corresponding epipolar lines. So in fact, if you take a look real quick, so you'll notice that, you know, here's a point right on the bottom edge of that window, and this line lands right on the bottom edge of that window. So these are corresponding epipolar lines. Any point that's along this line is also going to be along that line. Let's see, does that really work? Let's see, it goes across this chimney thing. Yep, there it is, right there. Okay, so that's finding the epipolar lines by given the correspondences through solving for the fundamental matrix.